Hello and welcome to week 2 of Weather You Want to Know. I'm Roman, and today I'm going to be talking to you about snowstorm patterns and types. So there are 4 main types of snowstorm patterns that we look for here in the Mid-Atlantic. These are your simple storms, which are your Miller A's, your complex storms, which are Miller B's, clippers, and Arctic fronts. Now the 2 main types of storm systems that we get are simple and complex storms. Here's a diagram of them beside each other, but I'm about to dive into them a little more. So a simple storm, this is your classic nor'easter, where a single area of low pressure tracks from the Gulf of Mexico up the East Coast. Cold air is in place from high pressure inland with phasing of the subtropical and polar jets. The low rapidly deepens off the mid-Atlantic and northeast coast once it taps into the jet stream dynamics aloft, which results in a large swath of primarily snow with only a narrow corridor of mixed precipitation between the snow and the rain. An example of such storm occurred on January 2nd through 4th of 2018, where an area of low pressure rapidly deepened as it moved along the northeast coast. Now this storm resulted in upwards of a foot of snow across eastern portions of the area, with blizzard conditions also being experienced near the coast. And looking at the GIF below, you can see as the large mid-Atlantic cyclone moves off the coast, the snow swath left behind. But we also have complex storms. Now, in this case, a primary surface low moves towards the central Appalachian Mountains before weakening, with a secondary surface low developing off the coast and eventually becoming the more dominant low. Cold air is locked in place with high pressure in New England, which results in a large area of mixed precipitation of snow, sleet, freezing rain, and rain. Complex storms can be broken down even further into 2 primary scenarios. We have scenario 1, where low pressure develops over the central U.S. and moves east, and we have scenario 2, where low pressure develops in the Gulf of Mexico and moves more northeast or north. In either case, the primary low eventually weakens as it moves north towards the Ohio Valley, with all the energy being transferred over to the secondary surface low developing off the southeast coast, which allows it to deepen and eventually become the primary surface low as it moves along the coast. An example of one of these storms was January 22nd through 24th of 2016, where low pressure resulted in a large swath of very heavy snowfall as well as mixed precipitation across pretty much the entirety of the region. Raleigh got mainly ice, whereas Washington, D.C. got very heavy snow with totals of 18 to 30 inches. But we don't only look at these higher end snowstorms when we're looking at setups that give us snow. We also have our more minor accumulations, and these are often caused by clippers. Now with a clipper, the polar jet dips south, allowing for a weak area of low pressure to ride along it. With cold air in place, most of the precipitation falls as snow. And due to the cold, dry air, precipitation is light and brief, with generally only minor accumulations of snow expected. But this isn't always the case, as we saw on March 24th to 25th of 2018, where a clipper system developed with a lot more moisture than normally seen and moved into portions of southwestern Virginia, resulting in very heavy snowfall over a small localized area in southwestern Virginia, mainly in the Blacksburg area. But we also have Arctic fronts. With an Arctic front, it's a cold front that moves across the area with very cold air moving in behind the front, allowing for gusty winds and near whiteout conditions. High snow ratios counter the low QPF, which results in higher snow equivalents. By that, I mean to say that 1/10 of an inch of moisture generally results in 1 inch of snow. But in Arctic fronts, 1/10 of an inch of moisture results in more like 1.5 to 2 inches of snow, or a 15 to 20 to 1 ratio. So it doesn't take as much moisture to get more snow. And it doesn't take much total snow to create a lot of impacts on the roads when the surface is below freezing. So these can see potentially high impact for travel. An example of this occurred on January 19th, 2005, where only a few hours of snow occurred, but because that snow was very heavy and it came down with below freezing road temperatures, that 1 to 2 inches of snow resulted in significant travel disruptions, with average commutes extended to 4 to 8 hours. So that's just showing you how it doesn't take a lot of snow to create a big problem here in the Mid-Atlantic. But those are the 4 main types of snowstorm setups, or ways that we generally get snow here in the Mid-Atlantic. Thank you so much for listening, and next week, check back to see how to check your forecast. Thank you.